Welcome to my tutorial. Now I am going to talk about basic understanding of diode. What is a diode? A diode is a semiconductor device that essentially acts as a on-off switch for current. It allows current to flow easily one direction, but critically restricts current from flowing in the opposite direction. This is picture of a diode. And this side is anode is positive and this side is cathode is negative. This is symbol of a diode. There are different types of diode. Their symbol is like Zener diode, tunnel diode, LED diode, photodiode, laser diode, varactor diode. What is inside a diode? Diode consists of semiconductor material such as silicon, germanium, selenium. This is picture of silicon, germanium. Some diodes are consist of metal electrode in a vacuum chamber or filled with a pure elemental gas at low pressure. Diode consists of N-type and P-type semiconductor material. N-type consists of excess of free electron, which are majority charge carrier, and hole, which are minority charge carrier. And P-type has excess of hole, which are majority charge carrier, and electron, which are minority charge carrier. By doping, N-type and P-type semiconductor consist. Here for N-type doping. When adding pentavalent atom like phosphorus in a silicon crystal, N-type semiconductor consists. Phosphorus outermost orbit has 5 valence electron. Out of them, 4 bonding with silicon valence electron. But there is extra electron excess there, which cannot participate in bonding. This electron can freely move. By this free electron, N-type semiconductor consists. P-type doping. When adding trivalent atom like boron in a silicon crystal, P-type semiconductor consists. Boron outermost orbit has 3 valence electron, which are bonding with silicon valence electron. But there is a free space for bonding. This free space called hole. By this hole, P-type semiconductor consists. How diode consists? When P-type and N-type semiconductor placed together, p-n junction form. As N-type has excess of free electron and P-type has excess of hole, which are close to each other. For this, free electron attracted by the hole. Thus, free electron migrate from N side to P side and hole migrate from P side to N side. Both side electron and hole are recombined. The free electron migrate P side by filling hole become negative ion. Similarly, the electron that left the parent atom become positive ion at N side. This net negative charge prevent further flow of free electron because negative ion repel free electron. Similarly, hole cannot migrate. This immovable charge near the junction act like a barrier or wall. This barrier creates an electrostatic field which has some potential. Its value is 0.7 volt for silicon diode and 0.3 volt for germanium diode. Forward bias. When P-type region is connected to positive terminal and N-type region is connected to negative terminal, the junction is called forward bias. Due to the positive terminal of the source, electrons that participate in covalent bond creation in P-type region will be attracted towards the positive terminal of the source. On the other hand, due to the negative terminal of the source, electron repel to the positive impurity ion of N-type region. When switched on, electron move from negative impurity ion to the positive terminal of the source. On the other hand, electron injected to n-type region and start combine with positive impurity ion. The electron move from negative ion, create new hole in the layer. On the other hand, electron combine with positive ion, generate free electron inside layer. In this way, the weight of positive impurity ion reduce and finally vanish. After disappear depletion layer or barrier, there is no obstacle of flowing current through the junction. Electron can easily flow from n-type region to p-type region. Here source voltage must be greater than barrier potential voltage to flow current through the junction. If source voltage is less than barrier potential, there will be no flow of current. Reverse bias. When n-type is connected to positive terminal and p-type is connected to negative terminal, the junction is called reverse bias. Here polarity of source voltage and barrier potential is same. As n-type is connected to positive terminal, electron attracted by the source. When switched on, electron move towards the positive terminal of the source and create positive impurity ion inside layer. As p-type is connected to negative terminal, electron injected to this region by filling hole create negative ion inside layer. In this way, the weight of the depletion layer increases. Increase of depletion layer will continue until all voltage applied to the junction. Thus, there will be no flow of current through the junction. A little current will flow through the junction due to the minority charge carrier that are thermally generated electron and hole. If source voltage is sufficiently high, the PN junction conduct reverse direction or can be damaged. Characteristics. Vertical red line indicates forward current and reverse current. Horizontal violet line indicates forward voltage and reverse voltage. Brown line indicates current voltage characteristics. Here we see when forward voltage applied, initially there is no flow of current. After some voltage drop, current conduct. This drop voltage is barrier potential. On the other hand, when reverse voltage applied, initially very little current flow through the junction. Its value is -50 microampere for germanium diode and -20 milliampere for silicon diode. When a large voltage applied, current conduct negatively. This voltage is called breakdown voltage. Normally its value is -50 to -100 volt, but it can be higher than 1 kilovolt. Some applications. To regulate voltage, use Zener diode. To protect circuit from high voltage surge, use avalanche diode. To electrically tune radio and TV receiver, use varactor diode. To generate radio frequency and oscillation, use tunnel diode, gun diode, impact diode. To protect light, use light emitting diode. Here in this animation, electron flowing from D1 to D4, but it's obstructed by D2 and D3 because D1 and D4 is forward bias, but D2 and D3 is reverse bias. Now electron flowing from D2 to D4, but obstructed by D1 and D3 because D2 and D4 is forward bias, D1 and D3 is reverse bias. Now D3 and D4 is forward bias, D1 and D2 is reverse bias. In this way, current can be controlled by changing direction.